Ever wondered if you could really survive on your own, completely off-grid if you had to? One of the biggest hurdles isn't food or shelter, it's fresh, clean water. Today, we're diving deep into the world of passive solar desalination, exploring the tech that promises to turn undrinkable water into life-sustaining liquid gold, using only the power of the sun. Can these devices really provide enough water for you to survive? Let's find out. First, let's talk about the absolute survival limits. The average person needs about a gallon, or roughly 3.7 liters, of water per day, just to stay hydrated in a temperate climate. If you're in a hot, arid environment or doing any strenuous activity, that number can easily double or even triple. So, the first question for any off-grid water solution is simple. Can it produce at least a gallon of water per day, every day, reliably? Most commercial portable solar stills claim outputs ranging from half a litre to maybe 2 litres per day under ideal conditions. Right away, we see a potential shortfall. You'd likely need multiple units running simultaneously just to meet the bare minimum for one person. This is the harsh reality we need to start with. So how do these things actually work? The science is both simple and elegant. It's all about a pure phase change, a process we see in nature every day. Inside a solar still, sunlight passes through a transparent cover and heats up the salt water or contaminated water below. The water absorbs this heat, causing it to evaporate, leaving salts, minerals, bacteria, viruses, and heavy metals behind. This water vapor, which is pure H2O, then rises and condenses on the cooler inner surface of the cover. Gravity does the rest, pulling the condensed droplets down a channel into a collection reservoir. It's basically a miniature man-made water cycle. The key here is the term pure phase change. Unlike filtration, which physically blocks contaminants, distillation separates the water molecule itself. This is why it's so effective against a wide range of impurities, from dissolved salts to microscopic pathogens. The efficiency depends on a few factors: the intensity of the sun, the surface area of the water, and the temperature difference between the evaporating water and the condensing surface. A bigger temperature gap means faster condensation and a higher yield. Now, for the fun part, a head-to-head performance test. I've gathered several different types of portable solar distillers. We have a basic inflatable pouch-style still, which is lightweight and great for bug-out bags. We also have a more rigid, semi-permanent model with a black basin to maximize heat absorption. And finally, I've built a DIY version using common materials just to see how it stacks up. We're going to set them all up side by side on a clear, sunny day. Each unit will be filled with the same amount of heavily salted water, simulating seawater. We'll measure the output every hour to track their performance throughout the day. My hypothesis is that the rigid model with its insulated, black-bottomed basin will outperform the others, as it's designed for maximum solar thermal efficiency. The inflatable one might struggle with maintaining a good shape for optimal condensation. The DIY one, well, that's the wild card. The results from this test will be crucial. We're not just looking at total volume, but also the rate of production. Is it a slow, steady trickle all day or a burst of production during peak sun hours? This tells us a lot about its practicality in a real-world survival scenario. After a full day in the sun, the results are in. As predicted, the rigid, purpose-built distiller was the clear winner, producing just over 1.5 litres of water. The inflatable still came in second, managing just under a litre. My DIY contraption, while functional, lagged behind at about half a litre. So even our best performer fell short of the daily survival minimum for one person. But is the water it produced actually safe to drink? This is where purity testing comes in. I'm using a TDS meter, which stands for Total Dissolved Solids. It measures the concentration of inorganic salts and organic matter in water. Our source saltwater registered over 35,000 parts per million. Let's test the distilled water. The winner is, wow, a reading of just 3 parts per million. That's incredibly pure, even cleaner than most bottled water. This confirms that the distillation process is extremely effective at removing salts. But here's a critical point many people overlook. Water that is this pure, essentially demineralized, isn't ideal for long-term consumption. Your body needs electrolytes like sodium, potassium, and magnesium to function properly. Drinking completely pure water can actually leach these essential minerals from your body over time. So, for a long-term survival situation, you need to remineralize the water. You can do this by adding a pinch of clean sea salt if available, or better yet, using specially formulated electrolyte powders or mineral drops that you've packed in your survival kit. Another simple method is to drop a few clean, sanitized rocks into your water container. They will slowly release trace minerals back into the water, making it healthier to drink. Never forget this step. It's just as important as the purification itself. So, what's the final verdict on using portable solar stills for off-grid autonomy? They are an incredible piece of technology, capable of producing ultra-pure water from virtually any source using only the sun. For a short-term emergency, a coastal survival scenario, or as a backup in a larger system, they are invaluable. However, relying on them as your sole source of water is a risky proposition. The low yield means you would need a small army of these devices just to meet the basic needs of 1 or 2 people. And that's assuming you have consistent, strong sunlight every single day. A cloudy day could be a disaster. A more realistic off-grid water strategy would involve a multi-pronged approach, rainwater harvesting as your primary source, a high-quality filter like a Berkey for bulk purification, and a solar still as your ultimate backup for dealing with saltwater or heavily contaminated sources. Solar stills are not a magic bullet, but they are a vital tool in the prepper's toolbox. They represent a fascinating intersection of simple physics and life-saving technology. Thanks so much for joining me on this deep dive into solar distillation. I hope this gave you a realistic and practical understanding of what this technology can and can't do. If you found this video helpful, be sure to hit that like button, subscribe for more content on survival tech, and share your own experiences with water purification in the comments below. Stay safe, stay prepared, and I'll see you in the next one.